So now that we've talked about the different types of data that we can collect and populations and samples, we need to talk about how we actually collect the data. And so we need to talk about what different samples there are, how we're going to get a good sample that is actually representative of the population. So we're going to talk about our different sampling methods. Our first sampling method we're going to talk about is called the simple random sample. This is the very kind of best type of sample, really. It's where every member of our population has the same equal probability of being chosen to be in the sample. A simple random sample is where every group of members also has the same probability of being chosen. And so simple random samples are the very best because everything's completely randomized. We're not accidentally picking too many of a certain type of individual because of the way that we're getting people to be in our sample. And so this is where, if, for example, if you just had the names of people in your class and you all on slips of paper, you put them in a hat, and you just randomly pick out some names, that's going to be a random sample because it was the same chance of everyone being chosen. Now, sometimes you want to make sure that certain representations, certain portions of your population are represented in different ways, different proportions. So that's where we get to stratified sampling. And in stratified samples, we take our population, we divide them into different groups, subgroups of our. And so, for example, maybe I'm going to separate by age, and say, I'm interested about some voters, how voters feel about things, but I'm going to look at voters aged 18 to 25, 25 to 40, 40 to 60, and then 60 plus. And I separate into different groups, and then I take a random sample from each of those groups. And this ensures that I'm going to actually get a representation of each of those age groups. Because if I do a simple random sample, it's possible, though not likely, it's still possible that I end up with a sample of all, 75-year-olds. And that would not be representative of the population. So a stratified sample is we separate it into our different groups, and then after we've got our groups, we pick a random sample from each group to make sure that we've got representation from each group. Okay, the next is kind of a variation on that. It's called quota sampling. And this is where we just are collecting from each subgroup, but we specifically make sure that we're going to reach some type of quota. And so, maybe say I need at least maybe 10% of this group, or at least 500 people from this group, or, whatever it is. I set some threshold that I have to reach. And then once I've reached that, then I've met it. And so that's quota sampling. Next is cluster sampling, and cluster sampling is it's similar in stratified sampling in that we separate into groups. However, we don't then pick individuals from every group. We instead pick some of the groups, and that's going to be our sample. And so maybe, for example, I'm interested in knowing how people in my housing development feel about something in our community. And so I'm going to separate by street and say, well, people on this street are in one group, and people on this street are in one group, people on this street are one group. But then I don't pick people from every street. I just pick a couple of streets and say, I'm going to collect data from everyone on street 1 and everyone from street 4 and everyone's from street 5. And that's a cluster sample. So I've separated into groups, and then I take everyone from some of those groups. And that's a cluster sample. Okay, next is a systematic sampling. And a systematic sampling is where you have access to your entire population, and you're going to pick every nth member of the population in some way. So maybe I am interested in knowing what the students in a statistics class feel about grading policies. So I stand at the front door and I pick every fourth student that walks in and ask them a couple questions. And so every fourth student comes in and they're in my sample. And I go until I've gone through everyone in the class and gotten every fourth student. That is a systematic sample because I just chose this rule every fourth person. And it could be any number I want. It could be every 2 people, every 7th person, every 29th person. Okay. And it just kind of depends on how big your population is and how big you want your sample. Let's look at some examples and see if we can identify what sampling method is used. So first, suppose in a particular state that previous data indicated that the electorate was comprised of 39% Democrats, 37% Republicans, and 24% Independents. In a sample of 1,000 people, they would then expect to get about 390 Democrats, 370 Republicans, and 240 Independents. To accomplish this, they could randomly select 390 people from among those voters known to be Democrats, 370 from those known to be Republicans, and 240 from those with no party affiliation. So here we're getting our sample. First of all, it's not completely random, right? We're not just randomly picking people. We first have groups. And so because we have groups here, this is either stratified, quota, or cluster samples. And a cluster sample, of course, is where you've got your groups and then you pick everyone from each group. Well, we're not picking all the Democrats or all the Republicans or all the Independents. Okay, and so this is not a cluster sample. Okay, so we've got this is either stratified or quota sampling. Now, every quota sample is actually a stratified sample as well. But our question is, are we actually representing every group here? And we definitely are. We've got our 3 groups. We've got Republicans, Democrats, and Independents, and we're making sure that each is represented in our sample. So this is a stratified sample. The question is, are we trying to reach a quota? And this specifically says that we are getting to 390 people from Democrats, 370 from Republicans, and 240 with no party affiliation, so that we could match the expected outcome of 39% Democrat, 37% Republican, and 24% Independent. And so because we're trying to match that expectation, then this could actually be a quota sampling. So I'm going to go and write it is a quota. This is quota sampling. However, because every quota sampling is a stratified sample, so this is stratified as well. Sampling. All right, let's look at our next one. If we could somehow identify all the likely voters in the state, put each of their names on a piece of paper, and toss the slips into a very large hat, and then draw 1,000 slips out of the hat. Okay, that would be our sample. Well, we've got our voters, but we're not separating them by groups at all. So that takes out our stratified, quota, and cluster sampling. And we're not saying, we don't have all of our people and saying, oh, I'm going to pick every 5th person or something like that. So it's not systematic. This is just completely random, right? Everyone's got the same chance of being picked. And so this is a simple random sample. Simple random sampling. All right, finally, if the college wanted to survey students, since students are already divided into classes, they randomly select 10 classes and give the survey to all the students in those classes. So here we have our population is all the students, and they're naturally divided into different classes. And so they're divided into these different groups, and we are picking just some of those groups. We're not making sure that every group is represented here. And so when we pick a few of the groups, that is a cluster sample. This is cluster sampling. Let's look at a few more examples. A pollster calls every 100th name in the phone book. Well, this should be pretty obvious. We have got a list and we're going through and picking every 100th. That is classic definition of a systematic sample. Systematic sample. Okay, systematic samples where you pick every nth person out of your population. Okay, next, every fourth person in the class was selected. Well, that's the same thing. We've got our whole class. We pick every fourth person. We skip, 3 people, and that also is a systematic sample. Systematic sample. Okay, next, a sample was selected to contain 25 men and 35 women. So it sounds like we wanted to make sure that we got men and women in this sample. And it's not quite clear whether or not we had to make sure that we were reaching some quota, but it kind of seems like that to me, at least. We want to make sure we had 25 men and 35 women. And so that is a quota sample. Okay, we've got here a website randomly select 50 of their customers to send a satisfaction survey. So there's no groups here. We're not picking every nth visitor to the website or anything. We're just randomly pick. Okay, and so randomly picking something, that is a simple random sample. Simple random sample. Okay, our next one, to survey voters in a town, a polling company randomly selects 10 city blocks and interviews everyone who lives on those blocks. So we've separated into groups here. Okay, we've got our voters, but we're separating by block, so where they live. And then we pick everyone in a few of those blocks. And so not every block is being represented. And so that means that we have a cluster sample. Because we are picking a few groups and getting everyone from those groups. So all of those ways that we've talked about sampling, those are pretty good ways to sample, but we do need to talk about bad sampling, because it's important to recognize that there are bad ways to sample, and a lot of things that we see actually in our world today, a lot of news articles and stuff, are actually based on bad samples. And so it's important to be aware of them. So there's kind of 2 main bad sampling techniques that are used that you should be wary of. First is convenience sampling. Convenience sampling is where your sample is chosen because the individuals are convenient to get to, and so maybe that's I'm in a college class and I'm interested in knowing how students at my college feel about a certain policy. And so, I'm just going to ask everyone in my class what they think about it. Well, that's not a great sample because I just got it because it was convenient to talk to everyone in my classes. And that may not be, and probably is not very representative of the student body at large. If I'm an art major and I ask everyone in my art classes how they feel about certain policies, art majors tend to think very differently than maybe a science major or a business or something else. And so convenient samples are pretty bad. The next is voluntary response sampling. This is where you just ask people, or you let people decide that they're going to be in your sample. And so this could be something like you're just standing on the corner of a road and you say, come answer some survey questions and get a free candy bar. Or you just do some random number dialing and ask people to participate in a survey, and they get to decide if they're going to or not. That's a voluntary response. Okay, people are voluntarily choosing to respond and be in the sample. And of course, that's not going to be representative of your population, because the type of people that will volunteer to be to participate in a survey are different than the type of people that do not participate. And so that's another common bad way to sample. Let's look at a few examples and see if we can identify which these are. So a pollster stands on a street corner and interviews the first 100 people who agree to speak with him. Well, this is, we're specifically talking here about people that are agreeing to speak with him. So that is classic voluntary response. Voluntary response. Okay. Next, a website has a survey asking readers to give their opinion on a tax proposal. This is a self-selected sample or a voluntary response sample in which respondents volunteer to participate. I didn't ask the question here, I just said it. Okay, it's a voluntary response sample because people are just being told to participate. Okay. And then third, viewers of a news show are asked to vote on the show's website. And of course, they're asking people to vote, so that's also going to be a voluntary response. Voluntary response. Okay, now you'll notice I didn't say anything here about these. None of these were convenience samples, but let me just point out actually that this first one actually does have a convenience element to it, right? This pollster stands on a street corner, so he picks a place and lets people come to him, and that has an element of convenience sampling to it, because he's not doing any extra work to try and get different types of people. He's at one spot and letting them come to him, and so this also has a convenience sample element to it. And you'll actually often see this, that a sample doesn't have to be just one type of sample and that's it. There can be different elements of them, and very often voluntary response and convenience samples kind of go hand in hand.